Hello everyone, my name is Tom and today I'm presenting CODA, a design assistant to facilitate specifying constraints and parametric behavior in CAD models. This research was performed at Hasselt University in Belgium with my colleagues Florian and Ramakers. Well-constrained parametric CAD models provide a great option to rapidly make derived designs, which allow for easy customization of shared models by novice makers. However, recent research shows that even trained students have a hard time reasoning about constraints. This phenomenon is even more pronounced in the maker community, as most makers are self-educated CAD users. On the other hand, tools that automatically inject constraints often fail to capture the intended behavior of the model accurately, as there are multiple ways to constrain a model and each constraint scheme conveys a different meaning. In contrast to automatically attempting to inject constraints, CODA assists the designer by providing suggestions. More specifically, CODA extracts relations in the model that are currently satisfied by the design but are not yet enforced by constraints. These extracted relations are presented to the user as possible relations that can be enforced by constraints. To facilitate the designer in deciding whether or not to accept a given suggestion, CODA visualizes the implication of the given suggestion directly in the actual CAD model. These visualizations allow the designer to make an informed decision about whether or not to accept a given suggestion. If, through the animation, the designer decides to accept a given suggestion, CODA automatically injects the necessary constraints into the model. Alternatively, if the suggestion does not convey the intended parametric behavior, the designer can decline the suggestion. To suggest constraints, CODA continuously extracts 4 types of relations in CAD models. The first type are relations with respect to the reference coordinate system, such as horizontal and vertical lines. Next, geometric alignments such as parallelism, perpendicularity, tangency, and so on are extracted. The third category deals with dimensional relations, such as edges with equal lengths or points in the middle of an edge. Finally, CODA extracts algebraic relations, which are relations in the form of mathematical expressions, such as an edge being 3 times as long as another. To keep this last category manageable, by default, CODA only extracts mathematical expressions that recent research has shown to be frequently used in CAD modeling. Moreover, these algebraic relations are not only applicable within a single 2D sketch, but are also relevant in 3D. As the user switches from a single sketch to the 3D view, CODA extracts relations across sketches and between sketch entities and modeling features. This allows, for example, for specifying a parametric laptop stand that can be customized to allow for different material thicknesses by linking different sketch lines with extrusion thicknesses. We envision CODA to complement the natural design workflow of the designer. As the user is designing, CODA continuously updates the suggestions. Moreover, as the designer selects entities in the design, CODA shows an extensive list of all satisfied relations involving the entities that are selected. Alternatively, CODA can be used to add parametric behavior to a design as a post-design step. For example, to convert a downloaded CAD model to a parametric specification. Although we believe the current version of CODA provides designers with an intuitive assistant to specify constraints and parametric behavior in CAD models, a user study we are currently planning will provide insights on whether CODA is only useful for novices or if it's also appreciated by more experienced designers, and whether CODA can help in teaching novices the basics of CAD modeling. Moreover, CODA opens other interesting opportunities for future work, such as providing advanced suggestions in the case of patterns and symmetries, or placing limits on the constraints to preserve the integrity of the model. With this, I would like to conclude my talk and thank you for your attention.